Hello friends, in today's video we are going to see number sequence problems. These problems are very common and famous in reasoning section of 11 plus exam. These problems test a student's ability to identify the pattern by applying a logical deduction or addition or multiplication, and the ask is to predict the next number in a sequence. So let's see what are the common type of number sequence problems are. So the very basic and common type is arithmetic sequence. In this kind of problem, there is a constant difference between a consecutive number. So if we see the first example, in this particular problem, if we see between all these numbers, there is a difference of 3. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14, and the next number would be 14 plus 3, which is 17. If we see a second example, between numbers 7 and 12 there is a difference of 5. Between 12 to 17 there is a difference of 5. 17 to 12 there is a difference of 5. So we can definitely predict what would be the next number after 27, which is nothing but 27 plus 5 is 32. Another example is in this particular problem, if we see there is a difference of number 3, but it's not an addition, it's a subtraction. So 15 minus 3 is 12, 12 minus 3 is 9, 9 minus 3 is 6, 6 minus 3 is 3, and the next number would be 3 minus 3, which is 0. Let's see what are the other common sequence problems are. So the another in list is geometric sequence. In these kind of problem, the consecutive numbers are either multiplied or divided by a constant factor. The very first example is, if we see in this, number 2 is multiplied with 3, which is giving us 6. 6 multiplied with 3, which is 18. 18 multiplied by 3 is 54. And the next number would be 54 multiplied with 3. If we see the next example, these numbers are divided by 2. So 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 8. 16 divided by 2 is 8, and 8 divided by 2 would be 4 at a final position. In example 3, we can see these numbers are definitely multiplied by 5. So the last answer would be 625 multiplied with 5, which is nothing but 3125. What are the other common number sequence problems are? The third type is Fibonacci sequence. In this type of problem, each number is the sum of last two numbers. So if we see into this example, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and the last number would be 8 plus 5, which is 13. In example 2, if we see, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21, and the last number would be 21 plus 13, which is nothing but 34. Third example is 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and 3 plus 5 would be 8 here. The fourth type of example in this number sequence problem is either triangular or square number. So in this type of problem, there is a triangular or square number pattern. So if we see the very first example, the difference between 1 and 3 is 2, then 2 to then number between 3 to 6 there is a difference of 3, then between number 6 to 10 there is a difference of 4, then 10 to 15 there is a difference of 5, and the next sequence would be 15 plus 6, which is nothing but 21. Another example is if we see the difference between these numbers, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, 21 plus 7, 28. So the next number would be 28 plus 8, which is nothing but 36. Third example is between 1 and 4, if we see there is a difference of 3, 4 and 5, there is a difference of 5. Between 9 and 16, there is a difference of 7. So it doesn't make any sense. So let's go back and then see, is there a different pattern? But if we see these numbers, they are square numbers of their base sequence. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. So by that way we can see the pattern is matching of square number, and the next number would be 6 square, which is nothing but 36. The fourth type of number sequence problem are alternate sequences, wherein in a series they follow two different patterns or two different type of rule. So if we see the first example, between 5 to 10 there is a difference of 5, but if we see between 10 to 8, it's a just difference of 2, which doesn't make sense. So now let's see, between 8 to 16 they are doubling, and between 16 to 14 there is a 2 difference, and then again 14 to 28 it's double. So we can see that it's following two different pattern. So the first pattern is doubling the number. So between 5 to 10 there is a double, then there is subtraction of 2, then again 8 and 16 there is a double, and then between 16 to 14 there is a difference of 2, and then 14 to 28 there is a double number. So the next number would be a subtraction of 2, which is 28 minus 2 is 26. If we see the second example, there is a difference between these first two number is 2, but after that there is a 1 decrease, and then again there is an increase between 2 to 4 as a 2, and there is again 1 decrease. So we can again see that this is following two type of pattern. One is addition of 2 and one is subtraction of 1. So if we see here, it's addition between 1 and 3 of 2, then 1 subtraction, then again addition of 2, then again 1 subtraction, then again addition of 2. So the next number would be a subtraction by 1, which is nothing but a number 4. Let's see the third example in this type of alternating sequence. So if we see the difference between these different numbers are, in first number we are doing the double, then subtracting by 5, then again here if we see it's not double, it's just addition of 10. So we go back and then see here we just have addition of 10, then subtraction of 5, then again addition of 10, then subtraction of 5, then again addition of 10. So this is how we can identify different pattern. Yeah, so the next number would be subtraction by 5, which is nothing but 25. So what are the common rules by which we can solve these number sequence problem? So first we should check, are we having a constant difference between consecutive number, which is going to put them in a arithmetic pattern. So in this example, if we see, there is a constant difference of 4 between each number. So the final number should be 26. Second type of problem is a geometric problem, where we will have a constant multiplication or division. So if we see this example, constantly there is a multiplication by 3. So the final answer would be 135 multiplied with 3. If the problem is not from arithmetic or geometric, we can also check if these consecutive numbers are following a alternate pattern. In this example, if we see, there is a alternate pattern between these numbers. So it's always between 2 to 3 there is a addition of non-number. So 2 plus 1 3, 3 plus 1 4, and then now here it will come as a number 5. And then second pattern is 8 minus 1 7, 7 minus 1 6. So after 5, if the number is coming, then it would be again 5. Also, we can check if these numbers are following any Fibonacci type of sequence, which is nothing but every number is a sum of its two previous consecutive number. So in this example, if we see 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. So this is how we can find out what would be the final number, which is nothing but 13 plus 8. If we do not see all these patterns applied onto the sequence, we can also check are these numbers are perfect square or cube or triangular numbers. Like in this case, if we see these numbers are a perfect square of 1, 2, 3, 4. We can also check if there are incremental changes in difference. So sometimes the difference between consecutive term changes in a consistent way. So if we see in this particular example, the differences are a consecutive numbers and they are consistent. So between these two numbers there is a plus 1, between these two numbers there is a plus 2, then plus 3, then plus 4, then plus 5, then there should be plus 6 difference, which is going to be number 22. If none of these criteria are matching into the number sequence, we can also check if we can find any pattern by going in a backward direction. But that will give us some sort of clue. There is also a possibility of a double sequence. So in this particular case, there could be a multiple sequences. So if we see the number here, there is a sequence of one increase. So 1 to 2, 2 to 3, and there should be 3 to 4. And if we see the reverse pattern, there is a 3 to 4, 4 to 5. So after a number here, there should be another number which is a 6 number. So what are the key tips to solve the number sequence problem? So while doing the number sequence problem, we have to be organized. We need to write down the differences in terms of pattern. Are there constant multiplier or division, or do we see a clear pattern in different consecutive numbers? Similarly, if one method is not applicable, then we need to also see if there are other rules which fits in. There could be alternate pattern, there could be constant multiplication, there could be a constant addition, or it may follow a different pattern within the number. The key of solving this kind of number sequence problem is the more we familiarize with the common pattern, it's become easier to spot the difference quickly and identify the final number. Also, by practicing a variety of sequences or type of questions, we can improve both our speed as well as the accuracy of solving this kind of problem. That's all in this video. If you have liked our video, please subscribe to the channel and give us a like button. Thank you.